Hello, Challenger. Today, we're going to explore the array data structure. So the array data structure is the most used data structure. We obviously use a lot, for example, ArrayList. We use the interface list as well. So today, we're going to be exploring what happens behind the scenes with an array. So the first thing to keep in mind is that an array has fixed size. What does that mean? It means that once we create the array, it's going to be that size, and there's nothing we can do to change it. Obviously, when we use an array list, there is an internal implementation that whenever the real array is full, another array will be created, usually with the double of the size. So keep that in mind that an array list actually has an array behind the scenes. And the other detail to pay attention is that an array, it's an ordered collection, and all the elements also has the same type. That's another detail to keep in mind. And what are the properties of an array? So an array has contiguous memory allocation. What does that mean? It means that whenever we create an array, this array will be contiguous. It's going to be created like all together, right? I can show you here one example. So when we create an array and we have those memory slots, for example, if we create this array here, 5, 6, 7, and 8, they're going to be all together. So you can't create an array and, create one piece of the array here and then the other piece of the array in the 27th. That doesn't work. An array is always contiguous, so they are always together, right? And the array is also zero indexed, which means that it starts from 0 and it has fixed size after initialization, right? And the other detail to pay attention about an array is that once you create an array, it's going to have the same type. So if we see the array of an array list, I'm going to show you that behind the scenes, an array from an array list is actually an array of objects. I'm going to show you very soon. And what are the operations of an array? So an array has random access, which means that we can access the arrays through the index with O1 of complexity, which means that we can do that very quickly. And for insertion or deletion, like in most cases, not in most cases, like this is the worst case scenario. So for insertion or deletion, we might need to shift the elements. And I'm going to show you how it works in code. And to traverse, it's ON. And we can also sort the array, right? And what are the main time complexities of an array? So to access an array through the index, it's O1. To search an element in an array, it's ON, because we're going to have to iterate over the array and check element by element. And if the array is sorted, then we have the complexity of O log n, right? And for insertion or deletion, in the worst case scenario, it's ON. Why? Why is that? It's because, for example, if the array is full, we need to create another array, and then we have to insert the element. And for deletion, we might need to swap the elements, right? So for example, if we delete an element in the first position, you would have to iterate over the whole array and shift all the elements to the left. So that's ON. And to traverse an array, it's also ON, because you need to, do the for each and go through all the elements. And to add an element, if there is a capacity, if there is a capacity in the array, the time complexity is O1, right? And if the array is full, then it's ON, right? And what about the memory for an array? So in the array, like I said, like if we create this array here, for example, that shows 5, 6, 7, and 8, they will be all located in the same memory space. So an array is actually contiguous, right? And for Java implementations, what do we have? So we have primitive arrays, could be an int, could be string could be an object, ArrayList, which is probably the most used collection class we use. And we also have the arrays utility class to sort an array, and we can find the quick sort methods there. If you take a look in the sort implementation, you're going to see the quick sort method. And what are the limitations? The limitation is that an array has fixed size, which means that if we create a neat array with the size of 10, we can't expand this created array, right? So what happens behind the scenes in an array list is that if the array is full, what they're going to do, they're going to basically double the size of the array that is behind the scenes of the array list. And we might have costly insertions or deletions because, like I said, like if the array is full, you would need to create another array, and it would need to pass all the elements from one array to the other for the new array, and we would have to add a new element. And if we need to, for example, delete an element in the middle of the array, we would have to shift all the arrays to the left. And this is ON, right? And there's no built-in methods for primitive arrays in Java. And what are the use cases? Well, we have many, right? So random access needs. So for example, when we need to access elements through the index, it's perfect because it's O1. And the array also has fixed collection size. Like I said, if you create a primitive array or a collection array, behind the scenes is going to be the same. That's why it's so important to know the fundamentals, because if you know array in Java, you know array in any programming language. It's the same. It's just, there'll be some differences here and there, but the essence, the fundamental is always the same, right? We can create also a matrix or grid representations with an array. And well, I already told you that, but we can go again. So there are some important details when deleting an element of the array. For example, when you delete an element that is not at the end of the array, for example, if we get this array here from 5, 6, 7, and 8, if we delete the element 6, then we need to shift element 7 and 8 to the position that the element 6 was, right? So, and this would be ON, right? But if, for example, the element is at the end of the array, then we don't need to do anything. For example, if you want to delete the element 8, then it's O1 because we don't need to shift any element. And leaving gap in an array is bad because, if you have a gap in the array, like lots of operations would mess up. That's why it's recommended to shift the elements. Right? And the insertion important details is that, well, it's pretty much the same here. So when you add an element and there's two space, shifting element is not required. So let's suppose we have an array of the size of 4, right? And we have 5, 6, 7, and let's imagine that 8 is not present here. So if we add an element after 7, it's O1 because, there is a capacity. So we just need to add an element in the end, right? And on the other hand, if we try to insert an element in an array that is full, then we need to create a new array. We need to copy all the elements 5, 6, 7, and 8, and then we need to add the new element in the new array. So this is ON, right? This is costly. So now to explore the other concepts of an array, let's check some concepts about the time complexity of an array in code, and then we're going to check some famous algorithms that are in code interviews. Let me show you here just a moment. So I'll just share here the screen. Okay, great. So let's see the time complexity of an array in practice. So this is an example of initializing an array. And as you can see, those 5 elements. So when we create an array, it's a fixed array, which means that we can't expand the size of this array, right? So we have those 5 elements. We have a neat array and a string array. And to access an array we have the time complexity of 01. So it's very quick, right? So to access the first element from Java mascots, it's just 01. But to search for an element in an array is different here, right? So it's different because we are comparing values. And to compare values, we need to iterate, we need to traverse the array, and we need to check if the element is equals, right? So this is on. So basically then to get an element based on the index, it's O1. It's O1 because an array is contiguous in the memory RAM, right? So that makes it very quick to access an array via index. And also, if we have the array sorted, so you can see that we have this array sort method. And if you notice here the implementation of this method, we are actually using the quick sort algorithm, right? And I highly recommend you to check the Java code so that you can learn a lot. You can learn about design patterns. You can learn about the fundamentals. So if you see, the whole Java language is based on fundamentals. And it's not only Java, obviously any programming language. And that's something very important to keep in mind, because if you really master the fundamentals, you can exchange tools very easily. Okay, so we have the array sorted. And now to search an element, we have O log n, right? So this is a lot faster than ON. And regarding insertion, so we create an array with 10 elements, right? And to insert those elements here, it's O1, right? But if you want to insert an element in the middle, and when I say in the middle, could be on position 1 or position 2, whatever. So when you do that, what you need to do, you need to shift elements to make room, right? So what does that mean? It means that, so for example, you have the insertion position 1, and you want to insert new Duke there, right? And basically, you're going to have to insert the new Duke in the middle, and you're going to have to put all the elements on the right that are on the right after new Duke. The same thing if you want to delete something, if you want to delete an element from the middle. So you have delete position 1 here, and then basically you're going to override all the elements after the deleted element. But if you are deleting an element at the end of the array, then it's okay. You just need to assign null to the last element. And to iterate or traverse an array, it's on as well, right? And on, what does that mean, on? So it means that it's the worst case scenario, right? And that's what usually they will ask you in the interview. So the worst case scenario is that we're going to have to, in this case, it's on, because, here, for example, we are traversing in all the elements. And to resize an array, it's also on. And this happens behind the scenes in an array list. For example, when the array is full and we want to add more elements, then they will do a similar logic than that. So basically, they will create a new array with double capacity, and then all the elements will be copied to the new array. So that's what happens behind the scenes. That's a very important concept to keep in mind, because all of the collection implementations are behind the scenes based on the fundamentals, right? And to update a value in an array, so in this case, it's O1 because we are accessing the element through the index, and we are basically assigning the value to this array. So it's O1, right? So let's see now some popular arrays here that we commonly find in interviews. So this is an algorithm to find the largest element in an array of integers. So I'm going to debug here just to make it simpler, right? So let me start debugging. So we pass the array here. It's 1 to 5. Firstly, we handle an edge case scenario. And by the way, this is important detail to keep in mind. when you're doing the interview, always ask about a possible edge case scenario, because if you don't handle those edge case scenarios, the interviewer might see that as a red flag, might be even rejected because of that. So we do this simple check, and we get the first element in this case. Like, this is very, very simple, okay? Probably you won't have such a simple algorithm for a coding interview, but basically you get the first value here of this array, and then you check which is the maximum. And obviously you also can't use the arrays max function, but this is, this is so simple, right? And then you get 5 back. Let's see one other algorithm. So given an array containing n distinct numbers, given an array containing any distinct numbers taken from 0, 1, 2, and n, find the one number that is missing from the array. So this is not that simple, right? So there are some approaches you can solve this algorithm. It's either using a math formula. Well, there are other forms to reach to the conclusion of this algorithm, but the most common ways to solve this algorithm, it's with a math formula or with a short technique, right? So let's see this math formula. And it kind of sucks to use this math formula because if you don't know it, like, it's pretty difficult to come up with this formula in the coding interview. And the short operator is also not very simple to use it, right? But anyway, I'm going to show you this formula, and, let's see this algorithm with the mathematical formula. As always, you always check edge case scenarios, and you get the mean, the max, actuals. So here you're going to get the mean and the max. And in those cases, you could use a Java formula, but, a Java function to get the mean and the max. But in an interview, like, it's usually not recommended to use the Java functions. But anyway, we're going to find the mean and the max numbers. And this is the formula. So it's max minus min plus 1 multiplied by min plus max divided by 2. And really, it would be hard to come up with this formula during an interview. So the best thing is to simply memorize that. If you go through an algorithm like that, either memorize this formula or simply, find another way to solve this algorithm. And there is also the SHOR method. And it's not very simple, this one, because SHOR is actually not something we use in our day-to-day job. So it's not something because, SHOR will actually shift elements from the binary number, right? So it's not something we would use in a business application. Like, this is more commonly used when you are coding a technical application, when you're coding something in a programming language, then you use this operator a lot. But otherwise, it's not very common. But anyway, let's see here. So we do the same thing here, right? So we get the mean and the max from this array. And we do a SHOR firstly from the mean to the max, and we have 1 here. And SHOR actual, then we do a SHOR with all the numbers, and we have 3. So we have 1 SHOR 3. And we could find the remaining numbers too. See, it kind of sucks to solve to this algorithm. Like, both cases, they work, but, in this case, either you need to memorize this function, this mathematical formula, you need to know about SHOR, and SHOR is not something we use in our day-to-day job. So, right. So, but for now, I would say just memorize that max minus min plus 1 multiplied by min plus max divided by 2. So there's a logic behind the scenes. And if you want to really memorize that, you need to understand the logic behind the scenes. Okay, let's see another algorithm. So this is an algorithm from LeetCode. And basically, the goal of this one is to remove the duplicate in place. So what is in place? So it means that we won't create another array. We're going to solve this problem in this array, right? So we're going to solve this algorithm in this array in place, right? So that's the meaning of it. And to understand this algorithm more clearly, Let's debug it. Okay. So we always, like I said, we always handle edge case scenarios. Always ask the interviewer, hey, is there any edge case scenario? Because if there is an edge case scenario, then you handle it, right? So, and we start from the second element, right? And we're going to iterate over the array. And we have 1, 1, 2. And basically here, let's see the numbers. We have 2, we have 1. So if those elements different, it means that the number is unique. So this is the new length of the unique array, which is 2. It's very simple as well. And I highly recommend you to do those algorithms on your own, because that's the way to practice them, right? Every time you're doing those algorithms, it's important that you time yourself. I like to use Pomodoro, for example. And while you're timing yourself, you can talk to a rubber duck, right? Why you're saying that to me, Rafa? Because in interviews, you need to explain your thought process. So usually if you start coding right away, you're going to be rejected right away as well. Why? Because the main goal of the interviewer is to see if you're a good problem solver or not. And if they see that you're going to solve a problem right away, it could mean that the interviewer might judge you. They might say, hey, because you went right away to the code, you didn't even plan what you're doing. So I imagine you're not a good problem solver. And during the interview is basically a judge game. So basically it's a sales process. So you're selling your skills during the interview. Reverse array in place. And so let's see here. Let's debug it. Edge case scenario. And this is a very common approach to solve arrays algorithms, the 2-pointer approach. Remember that. It is an important thing. So we have the left pointer and the right pointer. And basically we're going to check here if the left is lower than the right. You're going to swap element. It is very simple as well. But, even when it's very simple, you might have an algorithm like that. So, or this is what. So yeah, there we go. We have the array reversed. So by using the left and the right pointers, we can reduce the iteration times here. So it's an interesting approach. You could do that for reversing the whole array as well. It's up to you. It doesn't change much anyway. It would change a lot if the array was huge, but in that case, doesn't change much. And this array, it's a bit more challenging. Basically, the problem is to find 2 numbers in an array that add up to the target value. So basically, we need to find 2 elements that if we add them, it's going to be 9. So let's debug here. And this is one code challenge that you might have in a coding interview. So the first element here is 2. 2 minus 9. 9 minus 2, sorry. And we're going to check if this map contains this complement. Right now it doesn't. 9 minus 7. Now complement is 2, and this hash map we have the element 2. And if we see this null map, the main points here to remember about an array are the time complexity. Like to access an array, it's O1. To search an element in an array, it's O(n). To search an element in a sorted array, it's O log n. To insert an element at the end of an array, when there is capacity, it's O1. And to insert an element in the middle of the array, it's O(n), because you need to shift the element to the right. To delete an element from the end, it's O1, because you don't need to shift anything. And to copy all elements to a new array, you need to create a new array and copy all the elements. And also to update any element of an array, it's O1. Okay, so let me go back to the mind map. Okay, let me see. Live. Okay. And oh, I didn't show you the array in the array list. Well, probably you saw that, but if you've never seen that, notice that all the fundamentals we explored here today, they are implemented in the famous ArrayList class. So for example, the element of an ArrayList is actually an array of objects. And we have the default capacity. So which means that by default, the array will have the capacity of 10, unless you say something else in the constructor, right? In the constructor, You can also change the initial capacity if you want. And you can see that an array list behind the scenes is an array, right? And there is here many implementations, right? So there is this method insure capacity, grow array, right? So here, for example, we will create a new array, right? You can see the copy of new capacity. So it's very interesting to see what happens behind the scenes. And the isEmpty method is basically a check with the size variable, right? So basically the array list, what the array list class do, it basically encapsulates all of those fundamentals we explored from the array so that we don't need to do all of those things behind the scenes. Imagine if we had to, create all of this code in our business application. It doesn't make any sense, right? So that's the real power of encapsulation. All of those implementations are hidden here. We don't even need to know that. We just need to use the interface. And when I say interface, it's basically the methods. So yeah, that's just a curiosity. Probably most of you know that, but in case you didn't know that an array behind the scenes was an array of object, now you know it. And there are plenty of other objects here as well. There is the concept of generics. So it's very interesting, right? If you check the Java classes, you're gonna learn a lot. So the generic type of E. E, what is E? It's element, right? So it's very interesting. You can check the whole code here. And yeah, just wanted to show you that. Okay, let's go back. Mind map. No, actually the mind map is already there. So please let me know if you can access the mind map, because that's a good study tool for you. You can revise all the data structures. Okay, great. Thanks, Ron. Thanks, Roberto. Thanks, Benjamin. Thanks, Uma. Thanks. Okay, that will be a live of, I didn't understand that. Oh, a live of garbage collector, you mean? Could be, yeah. I need to prepare it, yeah, garbage collector. So I will first run lives about data structures, and there is still a couple of them. There is a live. So the next one is gonna be about key value data structure. The other one is gonna be probably about graphs. And graphs is a bit, intensive, right? There are some algorithms that are not so simple. Yeah, graphs, and there is still queues and stocks linked list, right? So there is still a couple of data structures, and we're gonna explore the main concepts of a linked list, like why we would have more advantage to use a linked list instead of an array list in certain scenarios. So there are plenty of interesting things to explore. And data structures is required if you want to pass in the coding challenges. Because, for example, if you got a coding challenge that is related to graphs and you don't know graphs, that's it. Basically, you kind of failed in the interview. How can you solve an algorithm about graphs if you don't know how to handle, if you don't know what's a graph, right? So, and like many big techs, even medium-sized companies, they will give you an interview about graph. So it's going to be nice. It's going to be a great concept to explore. So I'm looking forward to see you in the next one. So guys, thank you so much. And congratulations on focusing on your career to be here. And I'll see you on next Tuesday at 10 p.m. London time. Okay. So I wish you a great week. Any questions, just reach out to me in any social media. So see you. Cheers. Thank you so much.